This is your free body diagram quiz reteach video. Before we do the problems that you're going to correct, remind yourself of the following things that we're going to do for each problem. So we want to make sure that we read the entire question. We want to make sure that we draw a box, show the direction and the strength of the force acting by drawing an arrow, and then the names of the forces that we've drawn below. And then calculate the net force and circle it. So read the question, draw a box. You're going to show the direction of the force and the strength of the force by the size of the arrow. So big force, big arrow, small force, small arrow. Okay, and then we're going to label the forces with newtons. So this would be 10 newtons. And then the name of the force as well. So force applied. Okay, and then the net force on these problems is going to go in the box to the right. First problem says Riley and Connor were attempting to push Mrs. H on a wheeled chair with enough force so that Mrs. H would fall down the stairs. They figured out that they needed a force of 75 newtons to push her down the stairs. Riley and Connor were both applying a force towards Mrs. H. Riley was applying a force of 50 newtons to the left, and Connor was applying a force of 40 newtons to the left as well. Friction with the floor is 20 newtons. So the first step is to draw a box. If I go back into the problem, it says that Riley and Connor were both applying a force towards Mrs. H. Riley was applying a force of 50 newtons to the left. So here's going to be my arrow, 50 newtons to the left. And then Connor was applying a force of 40 newtons to the left. So I'm going to draw a smaller arrow for my 40 newtons. And the name for both of these forces is going to be the force applied. So we'll do force applied, F sub A. And then it says friction with the floor is 20 newtons. Forces act in pairs, and I know the name of the force that goes against the applied force is friction. So I'm going to draw a small arrow here, label it 20 newtons, and then the name of the force is F sub F for friction. So I want to calculate my net force. I have a total of 90 newtons going to the left, and I'm going to take away, if I add up both of the forces, 50 plus 40 equals 90 to the left, and then I take away 20 going to the right, and that gives me a net force of 70 newtons. And the direction that that net force would be going in would be to the left. Okay, so that's my net force left over. Question asked, do the students push the chair with enough force to knock Mrs. H down the stairs? It says that the students figured that they needed a force of 75 to push Mrs. H down the stairs. And you can see by doing the problem, they only have a force of 70. So that would be a no. Were the forces balanced or unbalanced? Well, I have a net force left over. So anytime that I have a net force left over, that would be unbalanced. The only time the forces would be balanced would be if my net force is 0. Problem 2. Owen has decided to pick up the hobby of roller skating. He's moving to the left with a force of 30 newtons. Normal force and gravity are 15 newtons each. The force of friction with the ground is 5 newtons. What is the net force? Okay, so he is moving to the left with a force of 30 newtons. So I'm going to draw my arrow here to the left. That would be 30 newtons. Okay, and he's moving to the left, so he is applying a force. So that would be F sub A. Next in the problem, it says normal force and gravity are 15 newtons each. So you would have had to remember from class and your notes and the example problems that gravity goes down. So that's F sub G for gravity. And normal force is the force that counters or goes against gravity. So this is F sub N. Okay, and they are each 15 newtons. So 15 for normal, that's a 15, and then 15 for gravity as well. Now it says the force of friction with the ground is 5 newtons. What is the net force? So if I'm applying a force of 30 newtons to the left, the force of friction is the name of the force that counters or goes against the force applied. So I know that the force of friction goes against my push. So this would be F sub F for friction, and it's 15 newtons. Okay, so my F net that's left over, I have 15 going down, I have 15 going up, so they cancel each other out. And then it's just 30 going to the left, take away 15 going to the right, will give me an F net of 15 newtons going to the left. So again, do I have any force left over? Yes, I do. 15 newtons going to the left, so the forces are going to be, oops, that's not correct. The forces are going to be unbalanced because I have a leftover force. Problem 3. A car is traveling to the left with a force of 900 newtons. Bus is traveling to the right with a force of 700 newtons. Friction with the ground is 100 newtons. Calculate the F net left over when the two vehicles collide. You may find it helpful to draw two separate boxes, but you don't have to. I am going to draw two separate boxes for this because I do think it is helpful to see it that way. So I'm going to draw a box for car number 1. I'm going to draw a box for car number 2. Okay? Car's traveling to the left with a force of 900 newtons. So here's my car traveling to the left. Force applied because it is pushing. And it would be 900 newtons. And says bus is traveling to the right with a force of 700 newtons. So right here we have 700 newtons, and that's also force applied. Friction with the ground is 100 newtons. So I have to draw friction with the car traveling to the left. It's moving on the road. Friction goes against it, 100 newtons. F sub F. And then I have to show friction for the bus as well. Okay, because they're both moving on the same surface, they both experience the force of friction the same way with 100 newtons. Okay, so that's force of friction. So now I need to figure out what the leftover force is, or what the F net is when the two vehicles collide together. So to the left, or the the school bus to the left, or the bus to the left, it is 700 to the right, take away 100 to the left will give me 600 to the right. And then over here, the car going to the left, I have 900, take away 100 will give me 800 newtons. So I just have a subtraction problem here. Turns into the leftover force would be 200 newtons going to the right. And that's it.